Good morning, Lana. Welcome to today's math lesson. And our today's math lesson is going to be cross-sectional area of cubes and cuboids. And our main topic is going to be measurements. That is, we are going to deal with volume, capacity, and mass. So by the end of this lesson, we'll have dealt with volume, capacity, and mass. But you need to begin to know the cross-sectional area. Because from here, is we're going to be able to get the volume, and then the volume can be converted to capacity. Remember, volume and capacity are not the same thing, but they are related. One is given in cubic units, the other one is given in liters and milliliters. So I'm going to draw a cube here. A cube is a surface that a shape that has both sides equal, meaning that it doesn't have a length, a width, and a height, meaning that all these sides are equal. That is what you mean by a cube. That if it's a cube, if this is 3, this is going also to be 3, and this is also going to be 3. So there's a way that you'll be able to get the surface area. Surface area of this cuboid will be, you are given this, it's going to be this part. So the cross-sectional area is going to be 3 times 3. That is going to give you 9 centimeters squared. And cross-sectional area now is given in square units. Then from there, now you can get volume. I want to give you one here. If we have a cuboid which measures, this cuboid of mine measures, going to measure 6 centimeters on this side by 3 centimeters. So we are exactly looking for that face. And so, for us to be able to get that, now this one we call it base area. What is lying on the base there, what we call the base area. So the base area is going to be this, what we are going to see here. The length times width. And just as I think the length is going to be the longer side, 6 centimeters, multiplied by the other side is 3 centimeters. And this is going to give you 18 centimeters square. So that is going to be the cross-sectional area. So we use both base area and cross-sectional area to mean the area that you can be able to see. I want to give you another example here, Lana, of a shape. This is one of the easiest parts of this topic, whereby you are given this, going to be colored like this. You realize in this case, we cannot use the base area, because base area means the one that is touching the ground. This one is not touching the ground. The area that we have to identify or calculate is not touching the ground. It's on one side. And that's how we're going to talk about cross-sectional area, what you can be able to see. So the cross-sectional area in this case is going to be simply the length times the width. That is going to be 16 centimeters by 4 centimeters. And that is going to give you 64 centimeters squared. So you realize, Lana, there are times that you use base area. Base area is what is lying on the ground. Like when you place a box like this. This is a box. When you place like this, the part that is lying on the ground, we call it the base area. But when you put it like this, Lana, and they give you this part, calculate the area of this part, we cannot call this base area because it's not on the base. It's on just a surface that is identified. So we call that cross-sectional area. So you're going to identify, you're going to see questions. So the area of the base represents the area of the cross-section. But both the cross-section and the base mean the same. Only that the base one is lying on the ground, then the other one is just on the sides. So I'm going to give you a question here. having discussed that, I move very fast to volume of cylinders. So volume of cylinders, having known how to get the cross-section area, one has to move very fast to volume of cylinders. Not cylinders, but cuboids. Volume of cuboids and cubes. Volume of cuboids and cubes. I know we have done this before, but I want us to be very keen on what we are going to do exactly here. So you're given, find the volume of boxes in questions. You can also be given a rectangular room. I'm going to give an example. A rectangular room is 6 meters long. Let me write this, very, very important. Question. A rectangular room is 6 meters long, 4 meters wide, and 5 meters high. A, if the room is stacked, you know what stacks are? With boxes. The boxes of 1 meter cube. That is 1 meter cube. How many such boxes? How many such boxes will cover the floor to make the first layer? Will cover the floor to make the first layer. That is a question. Number two question. I'm going to write all the questions here. Number 2 question. How many such layers will be there? How many such layers will be there? Number 3. How many boxes will fill in the room? How many boxes will fill in the room? Lastly, what's the volume of the room? What is volume of the room? Now, for us to be able to calculate this question well, we need to draw that room. So we are told the room looks like this. It's a rectangular room. We are told that it's 6 meters long. So on the longer side is 6 meters and wide 5 meters. And it's 4 meters. 4 meters in wide rim and 5 meters high. And then now question number 1. How many, if the room is stacked with 1 cubic meter, how many such how many such boxes will cover the floor to make the first layer? We're talking about the floor here. We are not talking about the height. So for us to be able to know how many will cover the height, in that case, they are talking about the base area. Let's calculate the base area of this particular, the one that will cover the base. Here, fill here, and fill here. To make the first layer. So that's going to be 6 times 4. 24 such boxes. They are going to be 24 boxes. Then number 2, how many such layers will be formed? So how many layers? Meaning that we are going to include the height. Because if one layer if one layer is going to occupy 24, meaning that on the height there are going to be 5 layers. Because one, remember the cube looks like this. It's 1 meter by 1 meter by 1 meter. For you to be able to get how many layers, we'll get into we'll compare this height and this height here. So 5 meters or 5 of 1 meter. And you're going to remain with only 5. They are going to go here 5. These are going to enter here 5 times because the height is 1. So 1, 2, 3, 4, 5. They are going to arrange 1 meter 5 times. Then number C. Find the total number of boxes that will fill the room. Of course, the total boxes on the base, that is, you get the base area times the height. That is going to be, the base is 24 boxes, and on the height, there are going to be 5 boxes. That is going to give you 120 such boxes. I'm going to fill the room. Then the last question, Lana, is find the volume of the room. Volume is calculated by base area times height. So our base area, in this case, we are not talking about boxes. Our base area is 4 times 6, 24 meters. 24 meters. If you don't know how to use that, you can use length times width times height. Because this is not a cube, it has a length and width and height. So volume is calculated by length times width times height. So our length is 6 meters times our width is 4 meters and an height of 5 meters. And all this is going to give you 24 times 2, which is 4 times 5, sorry. It's going to be 120 cubic meters. So that is going to be the volume of that particular cuboid. I don't want to waste a lot of time with those questions because they are very, very easy questions. I want you to attempt Lana. I'm going to give you work here. While at home, and because it's during the weekend, I want to give you exercise 83. 83 runs from number 1 to 6 various questions. Then 84, number 1 to 5. So you are going to do exercise 83 and exercise 84. Do this work, do it well, and I know at the end of the day you will have known how to calculate either cross-sectional area of a given cuboid or the base area of a given cuboid. In a case where you're given already the area of the bottom, that means the base area, then you're told the height is this, and then you ask about the volume. You just multiply the base area times the height to get the volume. So volume can be given by getting the base area times height, or the cross-sectional area times height, or length times width times height. So whatever you are given, you are going to see which formula are you going to apply in each question. So it can be either this, this, or this. Where you're given cross-sectional area, multiply that by height. Where you're given base area, multiply that by height to get volume. Let me just write it here. Volume. All these are volumes. Can be given depending on the question now. Where you're given the base area, you know you multiply that by height. Where you're given the cross-sectional area, you multiply that by height. Then where you're not given any, but it's a cuboid, multiply length width times height, and you get simply the answer. So I want to wish you well. Until next time, Lana. In our next lesson, we are going to calculate cross-sectional area of cylinders. That one is very easy, I promise you. It will be a very interesting lesson, a very easy lesson that all of us will be enjoying at that time. So may God bless you. Be busy at home, calculate those questions, calculate them well, and ensure that you post that work for marking. That's how we can be able to measure how much we have given you, the knowledge we have imparted to you. and take these things very seriously so that we can be able to move forward together. God bless you. So the next question, Lana, we are going to answer number B. So we've said the one that measure 10 by 6, they are going to be 2. 1. This one, the top one, because we are told this is open. So the next one, how many faces measure 10 by 3? If you look at the face that shows 10 by 3 is this face. So 10 by 3, we have this one and the other one on the other side. On the other side, you have another face like this. So they are going to be 2 faces. Then number 3, how many faces measure 6 by 3? 6 by 3 is this face, length and width of these 3. So there's this one on this side, and we have another one on the other side. On the other side, the others are going to be 2 faces. And lastly, Lana, what is the surface area of the box? I'll give you a surface area by multiplying all these faces. So the first face is the one that is at the bottom. After we remove the open one, we remain the one with measuring 10 centimeter by 6 centimeter. So one measuring 10 centimeter by 10 by 6. That is going to give you 6 centimeters square. Number 2, this one here, which measures 6 by 3, and there are 2. So 2 measuring 6 by 3, that is going to give you 18. That is going to be 6 centimeters square. And then the one that measures 10 by 3, 10 by 3, there are 2. This is on the other side. So 2 measure 10 by 3, that is going to give you 30 times 2, which is going to be 60. Lana, if you do your calculations well, this is going to give you 156 centimeters squared to be the total surface area of that particular open cuboid. So this is how you do it, Lana. Very simple. These questions are very simple, and they will be found in every exam that you do. So they should be taken a lot of seriousness. So I want to give you work before I leave. I want to give you exercise 80. Exercise 80. That is on page 129 to 131. 129 through 131. The questions are run from question number 1 to 7, but they contain A, B, C, most of them. So I need to do this work very well. Draw the diagrams where necessary. They will assist you to know which places are not there and which ones are there. So do it so well. After doing it, take a portrait of that particular photo and forward to me for marking, and then I'll return back you the results. So I want you to take that work very seriously. Follow the steps that we have shown here for you to be able to get the correct answers. So until next time, Lana, I want to wish you well. I want to stay home and stay busy. Every time, be doing something and continue praying. Pray for the whole country. Pray for your teachers. Pray for everyone. Pray for your parents, so that the country will come back to normal and things will continue as normal. May God bless you and have a wonderful day for you. Thank you.